Hello viewers, Mr. Nyati here again. This time around we're going straight to question B5 of the 2025 Science Paper 1, which is Physics, and we are going straight to question B5. Like my video, share the video and leave a comment in the comment section. Question B5, as illustrated here, shows a wave. Okay, so figure B5.1 shows a wave with frequency of 40 Hz. Then you have this wave here. Now it is important that you should be able to know how many waves are here. Look at this, because when you look at the wavelength, okay, the distance between two successive crests or two successive troughs. So here you have this, here you have this, okay. Now look at where the wave is starting from. This wave is starting from here, meaning it ends where it starts from here. This is one wave, okay? It is one cycle. Another one starts from here and ends here, here. This is another wave, okay? So this is what you ought to know. Now, under this wave, you have certain things that you need to know. So you have the distance from the resting position to here, the maximum displacement of the particle of the wave in the wave. This is normally called the amplitude, okay? So by definition, amplitude is the maximum displacement of the wave from the rest position, or the maximum displacement of the particle of the wave from the rest position. That is what the amplitude is. The wavelength is the distance between two successive crests, or the distance between 2 points that are in phase. Okay, those are some of the things that you need to know. So now the question says define amplitude. Please, waves is not something that you can fail, really. It's just about putting all effort and also knowing the wave equation that is at your level. It is speed is equal to frequency times wavelength. So now the first question says define amplitude. So here is the definition. So this is the definition of the amplitude. The amplitude is basically the maximum displacement of the wave from its rest position. What it means is this: if this is the resting position, this displacement, this one, is what we are calling as the amplitude. Okay, this is what we are calling as the amplitude, the maximum displacement of the wave from its resting position. We move on to B. Question B says calculate the speed of the wave. We need to find the data. What data can we collect from the question? Do we have because when you are calculating the speed, you need to know that the formula is speed is equal to frequency times wavelength, like that. Now, what do we have? Do we have frequency? Do we have wavelength? And the speed itself. That's what we're supposed to calculate. So now, from the question, what do we have? Well, we have, this one is the wavelength, because remember, this wave is starting from here and ends here. This is the wavelength, and the wavelength is 1.5 meters. What about frequency? We are told that the frequency, this wave has a frequency of what? 40 Hz. So how do we now do the calculation? We just multiply the two. So we're going to say 40 Hz multiplied by 1.5 meters. Okay, remember this is Hz. Okay, so what is the answer? If we say 40 times 1, it is still 40, and then 40 times half, it is 20. So this should be giving us 60 meter per second. This is the answer. We move on to question C. Find the period of the wave. Well, question C, question C. So the period of the wave, normally it is like this, because period is the time taken for one complete wave, but we don't have the time. The other formula could be period is equal to 1 over frequency. Do we have frequency? Yes. So this one we can't use it, we can only use this one. So we use this formula, period is equal to 1 over, what is the frequency? The frequency is 40 Hz. And then what is the final answer? We're going to say 1 divided by 40, and then the answer is 0.025 seconds. 0.025